we are going to learn new topics. Okay, so I just summarized what we have done so far. Okay, okay. What is high level language? So what we have discussed so far, Java is programming language. Okay, so it is high level language. High level language means human can understand the language which human can understand. We can generally call it as high level language. Those high level languages are not understood by the machines. Okay, so machine can understand only machine language or low level language. So whatever language you have written, those understand to machine kindly intermediate we can call it as compiler. Okay, compilers. So those machines are not understand your high level language. So who is required? Compiler is required. So then then your machine is understood by using the compiler. So not only Java, if any program understand that. So human can write, human understand high level language, but that language is not understood by the machine. So only compiler. So compiler convert your human language instruction to machine understandable language, machine language. So then machine can understand and it will execute. That will execute. Clear? And so before Java, we have some other languages also. If you take C, C++, those are exist before. But what is the problem with those languages? So for C language, so if you compile a C language in any the operating system, only on that operating system only you can execute C program. You cannot execute other platform or other operating system. So once you compile a C program in another operating system, because once you compile C program, it directly converted to operate like the .exe file that we discussed in our previous classes. So go on through that if you have any queries. Just I recap it what we have done before. Okay. So suppose if you are using predefined operating system, say suppose Windows, Linux, or all there are some. Okay, Unix like that. So in this case, what happened? So if you compile a C program in Windows, you can execute that C program only Windows operating system. You cannot execute in Linux or Unix. So if you want to execute Linux, also you have to compile C program that Linux platform. So how many operating systems are you using to execute your C program? Those many times you have to compile your C program. Okay. That is the drawback of the C. Before we discussed it. Okay. And that means your C language is platform dependent. So which platform is compiling? Only that platform only it depends. Okay. So only that operating system only it will be execute. Okay. And if you take Java, so Java is overcome the drawback. How? Whenever you compile a Java program, that particular program will not convert mission underline instruction directly. Means that exe file. It will compile an intermediate file called dot class file. So an intermediate file dot class file is generated. So that dot class file is contain bytecode. So it's a bytecode. Why we can call it as a bytecode? Once your Java file is compiled, dot class file, each instruction length is 1 byte. So we can call it as that is a bytecode. Okay. This bytecode, this dot class file is independent on operating system. Say suppose if I take Java program Windows, I compile a Java program in Windows, a dot class file is generated. You can take the same dot class file to Windows or Linux, any another operating system, you can directly execute without again recompile it of the Java program. Okay. So this dot class file is independent on the operating system. If you have a dot class file, from the dot class file, you will get source code. So if you have a dot class file, you can execute the dot class file. Your program will execute. That means the dot class file is very, very important in Java. Okay. That is the reason dot class file is independent on the operating system. Okay. So how do you get dot class file? So the previous class we have done some sample program, right? So that we can get the, so your source code will get the converted the dot class file after Javac we used. We will execute the dot class file JVMs. Whenever you execute, okay, that execute, when do you execute? The instruction should be underlining to operating system, then only that operating system will execute, right? So here, whatever dot class file you have, if you want to execute the dot class file, so generally who will execute? Java virtual machine. So if you are executing, if you want to execute dot class file in Windows related Java virtual machine, you have to use it. So if you want to execute dot class file, Linux underlining JVM Java virtual machine you have to execute. That is the reason whenever you have or want to download software, it is asking which operating system you are using. So you are in Windows or Linux, those Mac. So those flavors of installations only is giving, right? Why? Because in that software, those related virtual machines are available. So, okay. You can't use Java virtual machine of Windows to Linux, okay? Because the Java virtual machine is specified to that operating system only. But the dot class file is converted to a underlining operating system instructions. It contain bytecode so that dot class file is executed. So that class file means your Java program is executed. Okay. So that is the reason Java is platform independent. So dot class file is platform independent. So Java is platform. But coming to the JVM, so JVM, the main responsibility of JVM is executing your dot class file, right? So if you want to execute dot class file, once the instruction should be underlining operating system. So your JVM also depending on the particular operating system. So if you are using or in Windows operating, so your JVM is converted to Windows and write instructions. Okay, Windows instructions. That means your JVM is depending on Windows operating system. Okay, if it is Linux, depending on Linux. So Java virtual machines are depending on operating system. Your Java is independent on the operating system. So clear? So these dot class files are portable. Why we can call it as a portable? So you can take that dot class file and execute anywhere. Anywhere means any operating system. Okay. So that means you can compile once, run anywhere. So once you compile dot class file is generated, right? Say take that dot class file, you can take run anywhere. It follows write once, run anywhere. Java follows. So write one means compile once. Ora. Okay. So your Java write once, compile anywhere. Okay. So clear? That's it. So this is the classes we completed as of now. So I just recapping this. So in Java there is a feature called there is a feature called OOPS. Okay. OOPS means object oriented programming system. Okay. Object programming system. Object oriented programming system. Right. Object. Okay. Oops, object-oriented programming system. So if you take C language, so that is structure language. There is no class object concept in the C language. Okay. Did you create any classes in C language? Only we have functions, it's functions program. Okay, C language is a functions program basically. So it is not a object-oriented program. So if any language, you can say it is following object oriented programming system means it should follow few characteristics. What are those? Like I quickly write. So one is class. So one is class. Second one is object. Third one is inheritance. Fourth one is abstraction. Abstraction. And fifth one is encapsulation. Sixth one is polymorphism. Morphism. So దీస్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. ఇవి వచ్చాయంటే మీకు జావా ఆల్మోస్ట్ తెలిసినట్టే. సో ఇఫ్ ఎనీ ప్రోగ్రామ్ follows these six characteristics, it follows OOPS concept. Means it should follow these six characteristics. Okay. Class object, one is class, one is object, one is inheritance, one is abstraction, one is encapsulation, and polymorphism. So if any program does not follow any one of these, you cannot say it is an object-oriented programming system. It won't. Okay. If any program, inkedaina program, so it does not follow any of these class can object can inheritance can abstraction can follow pote, it is not a oops means object-oriented programming system kaadu. Just remember this. So when only it follow all these six characteristics, then only we can say object-oriented programming system. Example, Java is pure object-oriented programming system. And another example is .NET also. Okay, .NET also. Next. So what is class here? See, if I write a programming generally, what you write? So generally, variable, you write methods, blocks kind of code, right? So whatever code you are going to write, Okay, either method, functions, variables, blocks, anything inside a class. So what class characteristic tells that whatever program you write, whatever code you write, everything should be inside a class. So everything should be inside a class. So basically this class is a template, is a blueprint. Okay. So whatever code you are writing, everything you should write inside a class. So it is act as a protect to your code. So class is act as a protection of to your code. So no one can access directly your code. Okay. But if you want to access a class, whatever the code presents inside the class, object is required. So next characteristic is object. So suppose I have a class A, and I have some code inside a class A. So only a class object can access. That means you have to create that particular class object. That object only can access. So by using object, you can access the class content, a class. So object is real world entity. So object is real world entity. If I give an example, so if you want to construct a building, you need to plan, right? So for the plan, you are constructing a building. So which is visible to you physically? The building. Okay. The blueprint is not physically existing. So you are following blueprint and you are constructed the class according to the blueprint. There also class is a similar to a blueprint, and object is the replica of blueprint which can exist or which can visible. Okay. Object, the basic purpose of the object is to access the class contents, either variables, methods, or blocks, whatever inside the class. That is object. Inheritance means acquiring a properties from a parent. Okay. So in general, child can acquire from father color, height, behavior, some kind of properties, right? So inheritance. Okay. And child can acquire the assets from the parent. Okay. The properties by default. Here also inheritance means acquiring a properties from a parent. Suppose in Java, there is a parent class, there is a child class. In parent class, some of the variables and methods are there. So from the child class, you can directly access the parent variables and methods directly. Generally, if you want to access any class variables and methods, you have to create object only. That class object only you have to create. Okay. But the classes are inheritance here. Inheritance relation. So you no need to create a parent object. So the child object itself, we can access the parent methods. So you can create a child object. Also you can directly access parent things. So child has right to get parent assets. So by child object itself, you don't need to create a parent object. Okay. So it is something like this. Suppose there is a house. Okay. Only house owner has access to that, enter to that house. In that house, so house owner constructed the house. But if he has a child, he can also by default get access to the right? So he don't need to take any permission itself. Can go to can go inside the house. Similarly to that, if parent has anything, child can access that. So that is inheritance. Abstraction. So next is abstraction. So abstraction means, so what is required, he can display. What is not required, he can hide it. So let me tell you one example. So see, we have a switch and fan, right? So switch, if you want to, so if you want to operate a fan, just simply switch on the fan. But once you switch on the fan, how that particular fan is working, how electrical energy converted into the particular winding and mechanical rotational energy, you don't know. So you don't know, you don't need to know that those concept. But what do you want? What do you know? What is the fan switch? Where is the fan? That's it. So we can get service from that. Okay. Same. So what is required, you can display. What is not required, you can hide it. That is called abstraction. That is called abstraction. Here, simple concept. And encapsulation. So encapsulation means binding your variables to public members. Suppose you have a variable, so you have a method, but you don't want to directly give access to those variable to outside person. But the outside person can access to the value of the variable. Okay, outside person can have access to the value of the variable, but he should not modify the variable. So if you want to restrict that, you can create a variable private method. So private to that class only, and you can create a method, public method. In the public method, you can bind your private variable, so that any person wants to access that value, he can simply call that public method, so that he will get the value. For example, I have int a equals to 10. This is private. Okay, this is not accessible in outside, not accessible outside. So if you want not accessible outside, you just put private. So this is my private. So private. Okay. So this is not accessible, but outside person should accessible this X. So in that case, you have to just write. So in that case, what we have to do? So let me check it. Oh, so public. So there is a public method int. So get val. This is my method, public method. So this I have written a. So now what this method? So this private int a equals to 10 not accessible in outside. So only if you have to provide access to that outside person, so put public. So public, I told you, right? Public means anyone can access the value. Okay. So public int get value, only get value return a. So if you return a, so any outside person wants to access this 10 value, instead of accessing this variable a, here he can access get value. So whenever the outside person get val, so he will get the line the value of 10. So what happens if you give directly access to this a int a? So he may change the value, delete the value, or edit. Okay. So by mistake, if he edit the value 20 here, replace with 20, then the original value is gone. So if you are giving assigning any value, only variables can take the latest value. So it won't store the previous values. So it will overwrite the existing value. Okay. So that is the problem. So if you want to give access only the read to particular person, only provide the public method. So here you are binding your variable with a public member. So this is a public, right? So this is a private. So binding a private variable with a public method is called encapsulation. It's called encapsulation. Okay. Oh. And polymorphism. So polymorphism means one can exhibit multiple forms. So I give a particular example. Let me give some live example. So for your father, you are a child. For your wife, you are a husband. For your child, you are a father. So only one person, okay? In one person, different roles. So in one case, you are a child. In one case, you are a father. So one can exhibit multiple forms. Okay. So here also in polymorphism, ones can exhibit in different forms. So I give an example. So to here, so let me give one example. So 1 plus 2 equals to 1 plus 2 equals to 3. So this 1 plus 2 equals to 3. Now same one within the double quote, within the double quote, 2 equals to 1, 2. This is 1, 2. So here the same plus symbol in this case act as addition, addition. Here act as concatenation or join. Okay. So one can exhibit multiple forms. That is called polymorphism. That is called polymorphism.